Hello dear children, it's Naziya Ustad here from St. Joseph's High School. In this video, we are going to learn the introduction part of Chapter 8, Motion. In our earlier grade, we have studied about motion and its types. Let's have a quick review. Let's start with motion. In simple words, if a body is moving, it's described as motion. In slightly more technical words, motion is defined as a change in the position of a body with the time. Yes, change in the position with the time. For example, when an object moving from point A to point B, it's changing its position with the time. We saw that the time is also changing along with the position, so it is undergoing motion. What are the types of motion that we have studied previously? We have seen 4 types of motion. The simplest of all is the rectilinear motion. It is the motion of a body in a straight line. The example that we saw earlier is of a rectilinear motion. Object is moving in a straight line from point A to B. There is another type of motion that is circular motion. What can this type of motion be? It is the motion of a body along a circumference of a circle. Example, motion of the earth around the sun is an example of circular motion. The third type of motion that we saw is a rotational motion. It is the motion of a body around the fixed axis passing through the object. This is important. The axis has to pass through the object. Example of rotational motion is a ceiling fan, rotating along its axle. So you see that if I draw a hypothetical line called the axis of rotation, that it's passing through the fan. And the final type of motion is the periodic motion, which is the motion that repeats itself in equal intervals of time. Can you think of any example of this type of motion? Any object repeating its motion in equal intervals of time will be undergoing periodic motion. Assume an object is moving in a circle and it's covering each round in every 3 seconds. Is it performing a periodic motion? Absolutely. Since it's repeating its motion along same path in every 3 seconds, it's undergoing periodic motion. But wait a moment. This object is moving along the circumference of a circle, so it is also undergoing circular motion. So what you conclude from this example, we can say that one object can undergo more than one type of motion. Understanding scalars and vector quantities. Assume you are standing at this point. Now if your friend tells you there is a treasure pot 50 kilometers away from your home, how long will you take to find it? Which direction will you go? It could be here or maybe here. It is hard to know where exactly it is. You are only provided with the distance, which is one direction information. One directional information like this is called a scalar quantity. Your question to him would be, which direction from home? When you are told that it's 50 kilometers in the northeast direction, you have the precise information of the location. This now becomes two-directional information, distance and direction. The treasure pot is over here. Two-dimensional information like this is called a vector quantity. Scalar quantities are one-dimensional and vector quantities are two-dimensional. Speed is a very good example of what we call in physics a scalar quantity, indicating only magnitude but not specifying any direction. So that what the scalar quantities are? Only magnitude but no direction. In this case of velocity, however, the direction is stated, and that's why it is referred to as a vector quantity. A vector quantity involves not just the magnitude but also the direction. When you add directional information to speed, it becomes a vector quantity called velocity. System of units. System of units. The complete set of units, both the fundamental and derived units, is called system of units. System of units is divided into fundamental units and derived units. Following are the some system of units. First one is British Engineering System, CGS system, MK system. British Engineering System. In this system, the length, force and time are fundamental quantities. The units of length is foot, the units of time is second, and the units of force is pound. Centimeter gram second system, that is CGS system. In this system, the length, mass and time are the fundamental quantities. The units of length is centimeter, the units of time is second, and the units of mass is gram. Meter, kilogram, second, MKS system. In this system, the length, mass and time are fundamental quantities. The units of length is meter, the units of time is second, and the units of mass is kilogram. System International de Units, SI. In 1960s, an international committee established a set of standards for length, mass and other basic quantities. There are 7 basic quantities in SI system. So students, here I conclude this video. Further concepts will be covered in the next video. Till then, thank you.